Okay, so let's try some examples with the product rule. Example 1, we're going to use the product. You could do something else, and we'll talk about that in a second. But if I'm using the product rule, some people need to be organized, especially in the beginning. So that's where I'm using the UV notation. So you could do U and then V and then U prime and V prime, and then assign something to be U, the first one, 2x minus 3x squared, and V be the second one, 3 minus 4x. Now, listen, it's not required. I'm just saying you can. And then you do the derivative of U over here is 2 minus 6x, and the derivative of V is negative 4. So I know that it's going to, the formula was UV prime is equal to UV prime plus VU prime. So that means the derivative is going to be y prime is equal to U was 2x minus 3x squared. V prime was negative 4 plus, and then V is 6 minus 4x times U prime is 2 minus 6x. Technically, you're done right now, okay? It is not very useful in this form, so eventually you're going to have to be simplifying anyway, so we might as well practice that right now. So y prime is equal to, it's going to be negative 8x plus 12x squared. Let's say plus, then we have these two binomials here, so 12 outer negative 8 and negative 36, so negative 44x, and then last plus a 24x squared, and then combine everything, we're going to get 36x squared, sorry, that's my little doggy sneezing over here, minus 52x plus 12, like that. Eventually, when we're doing derivatives, we really want to factor at the end because most of the time it's very useful to find out where the derivative is equal to 0 because that's where we're going to have horizontal tangent lines where oftentimes we have something called a relative max or a min. So that's why those would be helpful in that case. If I looked at it and multiplied it together from the beginning up here, I'm going to put it up here at the top. We're going to get y is equal to, first is, oh, I don't need a parenthesis for that. Whoops. 12x. Outer is going to give me minus 8x squared. Inner minus 18x squared, last minus or plus 12x cubed, and then combine. I can rearrange it a little bit. I get 12x cubed minus, let's see, 26x squared, and then plus 12x. And then just using the power rule, y prime is equal to 36x squared minus 52x plus 12. Oh, look at us. We get the same thing. This here and this here are exactly the same. So either way is fine. I don't require one over the other. Just practicing the product rule, I use these just to show you, oh, look, the product rule gives us exactly the same thing. Now try B. Try B on your own first. So here's the answer to part B. Another way you could look at this, by the way, is it's almost like a crisscross if you organize it. Now, eventually I'm hoping you don't need to do this, but this is going to be one of the terms when you take the product of those two. And I could do it this way as well. That's the other two that are being multiplied. So like a little crisscross. All right, let's look at the next one. Now we're going to try without this organization. And again, it's just you follow what you need to do. So in this particular case, we have finding the derivative. My two functions, one of them is x and the other one is e to the x. So I'm going to try this without having to do a lot of the writing out. dy dx, and I'm going to do it in words. So it's the first function times the derivative of the second function plus the second function times the derivative of the first function. So that is going to be x. The derivative of e to the x is just e to the x, is plus, and then the derivative of x is just 1. So this is just going to be e to the x. So here we have the derivative of x times e to the x. Now, interestingly enough, down the road, and you don't have to do this yet, if I just ask you for the derivative, you're done, right? You have to actually find the derivative. You can't leave it as step number 1. But I was just doing that with words instead of u and v. Whatever one you like. Eventually, I'm hoping you don't have to write it out with u and v, but I get it if you need it in the beginning. Down the road, though, when we're doing the derivative, actually finding where the derivative is equal to 0 becomes important. So here, using factors like factoring it, you don't have to do it, but factoring it down the road will be helpful. So I can tell that the derivative of this would be equal to 0 when x is equal to -1 because that factor would be 0. And this factor will never produce a 0 because e to the x power will actually never reach 0. It'll approach it as x approaches -infinity, but it'll never reach it. Now pause and find part B. I already wrote out part B, so whoops. That should be the answer for that one here. Let's try example 3. So now we have two places. We have this one here, which is a product in and of itself, and this one is not necessarily a product, but it could have been. Ooh, let me pick a different color for that one. So let's do maybe blue for that. So that's the second one. So for the yellow one, the first term, I have to use the product rule. So that means when I write this out, y prime is going to equal to the first function and the second function are here. I'm underlining them each individually. So we have 3x times the derivative of the second function, which is sine. That's going to give me cosine of x, plus the second function, which was sine of x, times the derivative of the first function, which is 3. Plus, now the second one, it does look like a product, but because it is a constant multiple or multiplier out in front, you do not need to use the product rule. It's just going to be 5 times the derivative of cosine, which is negative sine of x. But if you look in part B over here, the second term has x squared times sine of x. That one you have to split up and use the product rule because this here in front of sine is not a constant. It is a function with a variable in it. But in our case here, for part A, you don't have to do that. So let's simplify that a little bit. We have 3x cosine of x plus 3 sine of x minus 5 sine of x. And that's y prime. Now you try B on your own. But remember, both of these, the first and the second term, are both the products of two functions. So this one takes a little more. Pause the video now and then do it. And then we'll check. Whoops. Still learning how to use this. So let's see here. So this is what I'm getting. Sorry about this, jumps around. This is what I'm getting for part B of example 3.